In this video, we're just going to do a summary of curve sketching, which is basically coming from the application of differentiation. Within 10 minutes, we're going to sketch and review the concepts behind the curve sketching using calculus. So that is the question we're going to solve. We're going to sketch that curve where y is equal to x cubed minus x. Okay, so just a few things that I want you to take note of. I want you to understand the two parabolas. Of course, we understand that there is a case where you have a minimum and then there's a case where you have a maximum. Okay, so the first derivative is basically what you get as you differentiate the given equation, the first thing that you're going to get. So in this case, we understand that our first derivative is going to be, so if you differentiate the equation we have, you're going to have 3x squared minus 1. Okay, so we've differentiated our function. So the way it basically works is this. So whenever the first derivative is positive, it tells you a function is increasing. So what is increasing? Increasing from left to right is going up like that. So if you look at the two parabolas, which parts can you identify as increasing? So this is increasing, then this is also increasing from left to right. So those two parts are supposed to be, the first derivative is supposed to be positive for those two parts. And then the other part where the first derivative becomes a negative, then it's supposed to be like this. So if you look at the two curves, so this is decreasing, that is also decreasing. Okay. Now, what differentiates these two curves? If you look at this part, here we've said the first derivative is positive. Okay, if you look at the two curves in red, that's positive. So what differentiates them is now either it's going to be a minimum or a maximum. So that is decided by the second derivative. Now the second derivative requires you to differentiate the first derivative. So the second derivative in this case is going to be 6x. Okay, so I believe you know how to go about your differentiation. So in such a case, you look at the nature. So when the second derivative is basically positive, it's a minimum. So when the second derivative is positive, it's a minimum. When the second derivative is negative, it is a maximum. Now, a case where it is equal to 0 is a point of inversion. So what exactly is a point of inversion? So a point of inversion is a point where it's like this. So we'll look at this, and then you can basically have again something like then part of the minimum. Okay, so this part where there's one part of a maximum, another part of a minimum, is what we call a point of inversion. So understand as we basically perform the sketching. So from what we've done now, let's basically get to sketch this. Okay, so quickly what I'm just going to do is I'm going to draw a line, okay, on the bottom like that. So use everything from there. So the first step to our sketching is to find the first derivative. Now the first derivative is basically equal to 3x squared minus 1. So from there, after you found the first derivative, we need now to find the turning points. Okay, so how do you find the turning points? We equate the first derivative to 0. So if you do that, you're going to have your x squared being equal to 1 over 3. So if you try to find the value of x squared, x is going to be plus or minus the root of what? 1 over 3. So we've got two values. One of them is negative, the other one is positive. So negative root of 1 over 3. And then we also have a positive root of 1 over 3. So these are the two turning points that we've actually found in this case. Okay, so we need to understand now the behavior of the curve between and outside the two turning points. So before the turning point, so if you want to make things easier for yourself, how can you look at this? So 1 over 3 is the same as 0.3 carrying. So obviously, if you look at the square root of that, what do you expect? So it's obviously going to be a value that is less than 1, right? It's a value less than 1. So therefore, I'm able to predict the fact that this is negative, the outside is positive, that a 0 is one of the numbers in between, And then of course 1 is greater than 1, the square root of 1 over 3, and then negative 1 is smaller. So we're going to use these as testing points to see the value of the first derivative. Remember we said when the first derivative is positive, it implies the function is what? Is increasing. So we'll start with the leftmost part. So looking at our first derivative, we'll plug in a negative 1. So you understand that each time you plug in a negative to an even power, it's a positive value, right? So your 3 minus 1 is going to give us a plus 2. So that plus 2 is a positive result. Positive result. So that is increasing. So this part is increasing. Now, what about if you talk about the part in between? So we can consider a 0 as I've put it. So if plug in a 0, this part is going to be eliminated. You remain with a negative 1. So you have a negative. Now, a negative first derivative tells you a function is what? Is decreasing. And then finally, the last part, which is a 1 as our testing value, which comes after the turning point. It tells us if you plug in a 1, you have 3 minus 1, so which is positive. So that part is supposed to be increasing. So we've now observed the behavior of the curve by using the first derivative. So we can quickly now find the second derivative to see what is going to happen. Now for the second derivative, it's going to tell us whether we're going to have a minimum or a maximum. So a second derivative, we found it to be 6x. So if you look at the 6x now, how basically do we get? So we get to test the turning points. That's the way it is. So if you plug in this turning point to find the nature, to determine its nature, if you plug in a negative value, the fact that it's x raised to the power 1, it will still be a negative. So it tells us, it being a negative tells us that the first part is going to be a maxima. So a maxima is that. Then this part is positive, so it's going to be a minima. Okay. So now, the points where these two graphs are going to join is what we call the point of inversion. So a point of inversion is where the second derivative is equal to 0. So if you find the value of x is going to be equal to 0. So x is equal to 0 becomes a point of inversion in this case. So with this piece of information, you should be able to sketch the curve. Okay. Now, how is it going to come out? So let's basically see using the piece of information we have. So this is our curve. That's our x or y plane. So our point of inversion is x is equal to 0. And then, of course, not forgetting that we have turning points to be negative root of 1 over 3, and then positive root of 1 over 3 as also another turning point. Then the point of inversion has been found to be x is equal to 0. So if you look at the curve x minus 3 minus x, if you plug in the point of inversion there, it's just going to give us a 0. So a point of inversion is 0, 0. So which is that point there. Okay. Now for the turning points. So for the turning points, we have one being a maxima, the other one to be a minima. So this is what we are now expecting. So this point is expected to be on top. This point is expected to be on the bottom, looking at the point of inversion. Okay. So the other one is expected to be a maxima. If you look at it, it's expected to be a maxima. So this point is supposed to increase. Then this point it will be decreasing before. That's what the curve is telling us, right? So let's try to see. So the sketch is going to be something like this. I'll use white. So that's a point of inversion. So a point of inversion is a point where you have one part of a minima, then again you have another part of a maxima, like that. So that's a point of inversion. Okay, where the turning is happening from. So now you can take another step. So this is why it was necessary for us to have a second derivative to find whether it's to be a maxima or a minima. And then the first derivative was telling us whether it was going to be decreasing or increasing. As we've seen, it's increasing in between the turning points. And then outside the turning points, we've seen that both parts are increasing as shown on the number line on the bottom. So you can also take a step by finding the y values. How do you find the y values? By basically substituting the turning points in the in the equation that we have. Now, for me, I didn't have a calculator, so in most of the cases, most of the assessments, calculators are not allowed. So a sketch like that one is good enough. Okay, so it's very, very easy to perform curve sketching using calculus. Okay, so these are the very few steps that you would have to understand. Okay,